So here we are, sharing secrets of the soil with me, your host, Regen Ray. Hello, soil lovers, Regen Ray here, and welcome to another episode of Secrets of the Soil. During my journey, I've spoken to a lot of people that talk about soil, and one of the words that took me a little while to understand and get my head around was this word agronomist. Till today, I probably still can't spell it, but it's just one of those things I never knew this role existed in the world of ag. And so today we are joined by Keiran, who is one of the agronomists and mentors at Best Farming Systems. Welcome to the show, Keiran.
Thanks, Ray. Thanks for having me.
Excellent. So agronomists play a big part. I think it's one of those words that if you're in the farming world, you kind of know what an agronomist does and who they are. But if you're kind of new to the space, it's a bit of a learning curve. Can you share with the soil lovers like the role of an agronomist and a little bit about yourself?
Yeah, sure. So an agronomist is basically an advisor. So our job is to oversee decisions that are being made on the farm. So depending what the farming system is, if it's a broad acre, there's a lot of advice given about chemistry or chemicals. So rates of herbicide to use, and you need to be aware of the timing. For example, if there's a residual and you can't grow a pulse crop by using that for 12 months, you have to be aware of that. So it's a little bit like a pharmacist, I guess, when you're working with a lot of different chemistry. And so my job, I used to be an agronomist for a large chemical company owned by Syngenta and Bayer. I was what's known as a reseller agronomist. So that was a really good experience. It gave me a really good understanding of all the different chemistry used and how it was used. I was actually raised on a cotton farm. So my parents grew cotton and I'm actually fourth generation. We were wheat and sheep farmers before then. So I've had the full spectrum of broad acre and stock and also irrigation and the intensity of all the inputs used. So it was a natural step to go into that world, which I did like. But after several years and once I had my three girls, I just didn't really want to be in such an intense chemical environment anymore. And my husband and I, we're broad acre farmers on both our family farms. So we were looking at just scaling back on the amount of chemistry that we used if we could in some ways. So I joined the Best team in 2018 when my youngest was a couple of years old, because I wanted to come back into that whole area of advising and helping farmers. That was what I loved the most about the job, was just being there as a sounding board and an advice for the farmer and just to assist and guide them. And I always wanted to make decisions that were best for their financial gain, not so much about directing them towards certain products. I was never that great at selling the shareholder-owned products, I guess because I am a farmer as well and I live on a farm and I just want to do what's best for the farmer. So that's why when I heard about Best and Bio-stimulant, which I'd never actually heard of a biostimulant then, back in 2013, biostimulant, the word didn't exist. It was known as a soil ameliorant, which a lot of people found hard to pronounce. And I was thinking, what is this? But within 5 minutes of hearing about what the biostimulant did, I was like, that sounds amazing. So John and I we tried it out on our farm, and that was back in 2013. That was actually a drought year. So initially it went out on just a wheat crop, and the crop actually failed just purely through lack of rain and lack of deep soil moisture. And then I think, so it failed. It was then grazed down to bare soil again by some stock, by some cattle we had. And then the following March, we actually had a rain event. And John and I were thinking by then, there's no way this product would still be hanging around. It's gone. And it was really interesting after that rain event, at half of the paddock where the TM, the biostimulant, was applied, that could be sown, that was holding its moisture. The other half wasn't. And we were like, oh, there's something going on here. So that was then sown into barley, and the other half of the paddock had to wait for another rain event to really get going. So because that half where the TM had been was already up and established in the timely manner of the window, it then was a better yielding crop. It was higher protein. And I think from memory, it went malt, which we'd never achieved on our farm. We couldn't really get above 9% protein. And we received $45 a tonne more So we were just like,
Wow.
wow. So that money, that $25 a hectare we spent on this biostimulant, we certainly got it back fairly quickly. So we were sold. And I then had the confidence as, I guess, a farmer, but also an agronomist to then take it out and start recommending it to people. And I was, pretty excited because I really wouldn't want to recommend something unless I know it's a good product and it's going to be of benefit to that farming system.
And that whole scene is believing really kind of helps. And I think with anyone in sales or, promoting or advocating for something, the more you experience it and have that kind of personal experience rather than just knowledge and fact sheets and what's on the data material, it comes from a different space. And like the fact that even the way that you've just shared that story and like that, there's this clear line of this half of the paddock had it, this half didn't. We could use this paddock earlier, just after one rain event, meant that you could yield a profit. And so that, is the proof in the pudding, I guess, as some people are waiting to see, and you've had it firsthand. With the whole agronomist side of things, what led you to be down in the agronomist? You were working on the farm, you obviously grew up as a fourth generation on the farm. What led you to the point of wanting to, be around the kind of chemistry side of the soil world?
Well, I think because I was raised on a farm, we were always like, I'm one of four girls. We were out driving tractors, irrigating, doing everything. Dad was great. We just helped all the time and we were very involved in the farm. And then I went off to Sydney and worked, in the corporate world, which made me realise I really missed the land. And I didn't really understand that I really did have a big connection with the land. And that's when I decided to then do an ag degree and return back to the industry. And at that stage, I wasn't really thinking of agronomy because I used to see a lot of cotton consultants who would come out. I think that's all I thought that was really involved. And they were called bug checkers back then. And I was thinking, I don't want to be a bug checker. But then the role came up in my local town and I realised it wasn't just bug checking. And even though we did a lot with cotton, there was a lot more involved, and also the broadacre side and just that administrative or the advisory side, which really appealed to me, just having that relationship with the farmers and being a part of their business and helping make decisions was really, really appealing. And I guess it gave me the best of both worlds. I could still have that business side as far as relationships, but I'd be out and about because I think from working in Sydney in a skyscraper, I really quickly became impatient with being stuck at a desk, at a cubicle, and just same old every day. I realised I really wanted that diversity. I wanted to be out. Every day would be different. And then it was great just really stepping into each farm and seeing how they were run. And then once I started really focusing on the soil side, I can really see that now as well, where I'm not only looking at just all the inputs and the chemicals that are used and the crops, it's all about how that impacts the soil and what, I guess, knock-on effects it has to the whole business. So from the time I've been with Best, I've had an even huger, I guess, awareness of how it's all interrelated, because when I was a full chemical agronomist, even though we were doing lots of advisory and lots of different inputs, we rarely ever focused on the soil. It was all about adding and what will help. And it was never, well, what can we do to preserve this soil or to actually help the soil to work for us? I was never taught, even through uni, that the soil actually is a living thing and that it has its own whole ecology, and we need to respect it and we need to get that benefit from it, because it's like a whole workforce that's there. And it's only since I've been with Best that I've become aware of that. So I've gone to a whole different plateau now in regards to, that's an amazing tool that we really need to respect and use. It's not just something that props the plants up that we keep having to add to all the time. In the industry I was in, it was the ethos that whatever you take from the soil or whatever that crop takes from the soil, you have to put back. You have to replenish it in as far as inputs, mostly fertilizer and other chemistry. So yes, when I soon understood that it's actually, unless you are, I suppose if you are in that system where you're not doing anything to stimulate your microbiome, you're not assisting it, you're not supporting it, then you are in that system. You do have to keep putting back whatever is taken. But that in itself is such a guess. Like, there's no way we could know exactly second by second what that plant needs. We're only really, it's mostly NPK focused, sometimes zinc. I've noticed silica's coming up lately. That's a lot of farmers I'm talking to, they're being told, oh, silica's good, you should add silica. But it's all depending on what's going on with that plant, what soils, what the conditions are, what the temperature's doing, what environmental conditions are happening. And that's something I don't think we could ever replicate. It's so clever. The whole system, it amazes me. The plants, or the soil and the microbes are so super intelligent, and they've been doing it for millennia. And even though we're pretty clever with how we can manipulate plants and soil, we're just still, I don't think we'll ever get to that point where we can guess exactly what that plant needs second by second, depending on what's going on in its external environment.
Yeah, so well put and so poetically said in regards that it's been happening for millennia, and for us to think that we can come in and control that system that just happens so, with so many moving parts is kind of a bit delusional in a way. So as a agronomist with this new mindset and this new approach of caring for soil, and what does it look like when you go out onto a farm now? What are you looking for and exploring, and what are some of the tests and profiles that help you now make better informed decisions when working with farmers?
So it's really important to actually get out in the farm, to actually walk through the paddocks. I can usually notice underfoot immediately. I can just by the feel through my steps of just what the sponge is like, I guess. If it's really hard, and for example, if I'm walking into a stubble paddock, if it's crunchy and brittle, then I know there's not a lot happening as far as you decompose of fungi and bacteria. And then that's before we even start to dig. And I also take a pentrometer with me. So that's a really useful tool, which is a measure of your soil compaction. And so that reflects on how hard those root systems have to work to penetrate down into the profile to access nutrients and moisture. But also if you've got a really tight soil, so with a pentrometer, for those who haven't seen one, it's just a pressure gauge. It's parts per second. It's KPI. So the KPI measurement, you want it to be between 0 and 300 is perfect. That means the soil has a very good structure, and the plants don't have to expend a lot of energy pushing their root systems down to access what they need. When it's around 400 to, I've even had up to 800, it's very hard to drive that pentrometer into the soil, and that reflects that the plant, it's going to expend a lot of energy trying to push that root system down through its whole growing season. So that then impacts the plant, because some of that energy that should be driven towards maintaining yield, health, just the overall growth, is just being concentrated trying to push and not really getting anywhere. So that's the first really helpful tool that gives a little bit of a snapshot of the condition of the soil structure. And if there are compaction issues, there's usually always a clay pan that we'll find. But I love to see how quickly that then disappears, because it's all about, when I initially see a farmer, particularly if they're just starting our program, we just like to run through some basic tests. So the pentrometer is one of them. We take those measurements. Also, if there's plants in the paddock, we'll take a Brix reading. So that's another really helpful tool that just gives an overall, I guess, look at the crop, how it's tracking along, if it's lacking in nutrition, depending on what sort of reading you get. It's a really useful tool if the farmer's a little bit on the fence whether they apply nutrition to the plant, or if there's insect pressure, how well that plant's going to cope. So that's another helpful tool that I always do. And most importantly is a shovel. It's that's probably the most important thing, just to get down and dig. And if you can, even if it's a weed, dig up a plant. And I always examine the root system. And from there, I can have a bit of an idea of what's going on. So if I dig up a really clean root that doesn't have any soil sticking to it, that's a bit of an indicator there's fairly low biological activity in that paddock, in that soil at that time. And that's because when it's low, the low presence of all the biology, because they will actually, when you've got the whole system functioning, that plant is, as you would know, it's photosynthesizing, it's pumping down carbon and sugars to feed those microbes. And in exchange, the microbes are saying, oh, thanks for that. Now, what nutrition do you need? And they will actually stick soil onto those roots through their little glues and waxes. So in return, those roots end up looking like dreadlocks, which is a really good indicator that there's a fair bit of biological activity going on there. So, and I always see that if initially the plants are clean or don't have many dreadlocks, within 2 to 3 years, we will see more and more dreadlocks or rhizosheathing emerging on the plant. So that's always a good indicator. And the other really simple way is just actually looking at soil and smelling it, because soil that isn't healthy does not smell, and it's always a lighter colour. So I work a lot where I live. I'm on the floodplains in the northwest of New South Wales, where we're traditionally a black-grey clay, and it's a very rich, very heavy soil. But it's really interesting. A lot of the soil I used to work with had no smell, and that's because it's lacking humus, it's lacking biological activity, and everyone forgets that soil is supposed to have that beautiful smell like you would smell in a veggie garden. And once you start to notice that soil change colour, it changes texture, all the air pockets return, so it gets all that lovely aggregation, and you can smell it, and it's so exciting. And so that's another indicator. And also I love if I find worms in the soil, they're a fantastic indicator that things are pretty good. If you're finding at least 3 to 4 worms per shovelful, and admittedly you do have to have a fair bit of moisture for them to be up on the top. So we didn't see a lot of worms during the drought years, but they are down deep. But those worm eggs, they will stay in the soil for up to 70 years. They will just sit there, and they'll only hatch when the enzyme conditions are back in the soil and in a comfortable, present environment for those worms. So they're a really good little indicator of your soil health.
Wow. When the environment is right, they will just flourish. I think, the way that you explain that, from just the moment that you set foot onto a farm, you can already feel it underneath your feet. And what you explained as well is using a lot of the 5 senses that we're born with, a couple of tools to help with, the compaction and maybe the bricks meter. But it's really using a lot of sight, smell, touch, visual assessments of the color of the soil. It's really nice to know that there are people with boots on the ground going out into the paddocks and really getting to understand the soil, rather than just, what did you grow last year? What did it take? Okay, well, you need to put, 250 kilos of this back. Most of it's nitrogen, which is free in the air anyway. And so it's like not really a system that's really connected. And I guess your recommendations, once being on a farm, come with a lot more, personal touch and experience of spending time with the farmer. How long would you normally spend on a farm to gain all the knowledge that you need for the recommendations? Like, can you see things pretty quickly, or are you spending like half a day on the farm? What does that visit normally look like?
Oh, look, I can see things fairly quickly. Like I do love to talk to the farmers, so
Nice.
I could easily spend, it's average 2 to 3 hours minimum, depending on the farmer. We always move around to different sites, but usually each little examination to each point we go to, we might only need 20 minutes if we're going to really just nut it out quickly. But it's a lot of conversation, and as you can see, there's a lot of explanation that needs to go on, and a lot of education, or just showing the farmer, and that's why it's so important to get out on the farm, because a lot of what I explain, and I talk to a lot of farmers remotely over the phone, but it's not until you're out in the paddock with them and actually really showing them. And even for myself, like I I love the concept of what the biostimulants did. But I was like, that sounds really good, but I still don't quite believe that would happen, especially, 250 mils. I just don't think that could really have much of an impact. So until the farmer actually does see it, and I really like to visit, particularly after second application, if it's the first year of using the biostimulant, because that's when you can really start to see things. And so I would spend, it's normally half a day. And I'm happy to give them as much time as they need, because it's really exciting for them. It's a lot of them actually enjoy getting some positive feedback and a bit of hope, particularly if they're in a position where they can see they're just not achieving anything. They've hit a wall, their yields are plateauing or even dipping downwards. They're spending more and more money, and they can tell their soil's not great. And it just to be reinvigorated and told, well, this is actually really easy to fix and very simple to fix, and you don't have to spend a fortune. It's they just really appreciate that. And I just really enjoy just hearing the history of their farm. Like I love knowing, what that soil's been through and what management, and then we can sort of piece together why it's in the state it's in, or a lot of them it's not going to take much. It's all there, but it's starting to degrade. So it's just a few tweaks and they're up and running again.
I think you make a very valid point as well in regards to a lot of people seeking these solutions when they kind of hit their wall, they got their back against the wall, or, they've spent a lot of money on inputs that aren't working anymore. And I think we can definitely nowadays see with a lot of case studies and conversations like this, that there can be a bit more of a preventative approach to this system before it's too late, or before, there is a sense of urgency, creating a little bit of a buffer. What are some of the things that farmers could be doing before they get to that point where it's devastating results or lack of yields, or, banks are knocking on their door and they're in debt and so forth? Like, when do you think is a better time for farmers to start exploring these type of systems before it's too late?
Oh, I think as soon as they can. The sooner they start, the better, because the more, for example, I can see what's happening at the moment, like even in my area where we're traditionally not a high fertiliser usage area, and we've been so lucky after we've come out of the drought, we've had several fairly good seasons where everyone's pulled off big crops. But I can see that a lot of farmers I'm speaking to are now being told, well, you've pulled off a big crop, you're going to have to replace. This is the old replace talk again. And so they're being asked to put out, 100, 150, 200 kgs of fertiliser. So they're at that tipping point where their soil is actually pretty good. The structure's still there, although it's starting to get some issues. And unfortunately, when they get onto that treadmill, they really can't get off it, because the more you keep adding, the more you need to add on, because it'll just shut down that system pretty rapidly, because those plants will, instead of, when they're photosynthesizing and taking that carbon, instead of gifting it down to the microbes, they'll then think, well, I've just been given a lot of fertiliser. I don't need to gift all this sugar and carbon to the microbes, and I'll just keep it for myself. So those microbes starve initially, and so they're just trying to get hold of any food source or carbon they can. So they then strip it out of the soil aggregates, which makes them compress. And that's why as soon as synthetic fertiliser is introduced onto a farm, the soil starts to harden up. It gets harder, it gets tighter. And then when we do those pentometer readings, you can't get it below 400. It's starting to really get harder and harder each year. And the plants also just become a little bit lazy. They're quite dependent and on being fed that synthetic fertiliser or that NPK or just the N. But what also I find a little frustrating is those products, I mean, they're good. I'm not knocking them. Fertiliser, I'm not anti-fertiliser at all. I think it has its place, but it needs to be used not in excessive amounts, and it's quite inefficient for what it costs, because I'm very aware of what farmers are spending per hectare, and that's what I'm all about helping them with, is just reducing their risk while also increasing their soil health but growing healthy, resilient crops without spending a lot of money. And unfortunately, a nitrate-based fertilizer, the plant has to work really hard to access it. So because, and I guess I'm getting into a little bit of technical stuff here, but I try and explain this to farmers all the time because no one explains this. Like the fertilizer companies do not explain this. They're all nitrate based, like your ureas, MAPs, DAPs. So they're all negative ions. So for that plant to access it, it has to convert those negative ions over to positive to actually access those enzymes or those amino acids. But for the plant to do that, it has to use 15% of its photosynthetic energy, which is not good because all that photosynthetic energy needs to be focused on that plant photosynthesizing as rapidly as it can, which is maintaining the yield and the health of the plant and also feeding those microbes below. So straight away that's deducted. But what really frustrates me is the plant also has to use 50% of its water molecules to convert that negative to positive to access that N. So particularly in a dryland situation, that is not good because that is drying out that plant quite rapidly and putting it under stress. And also if it's in an area where it's susceptible to frost, so those cell walls, because you're using all those water molecules, they're mostly filling with water, not as much cytoplasm. So they freeze really easily. So, of course, the crop is more susceptible to frost. It also has a lower Brix. So when we were talking about Brix earlier as being a good indicator as the overall health of your plant. So when the Brix is lower, which, really you want your Brix to be around 12, preferably 15 or higher. Plants that are heavily fertilised have a lower Brix. And when I do a Brix reading, I'll often see a very crisp line. So it's meant to be quite a fuzzy change in colour, which is an indicator that the plant is quite healthy and doesn't need much nutrition. But when I look at a crop that's been given a fair bit of fertiliser, I looked at a cotton crop a few weeks ago that had just had 150 kgs of urea applied and the Brix was fairly low. It was around 9, which it shouldn't have been. It was like 3 in the afternoon. It should have been around 18. But there was a really crisp line. It was white, then it was just blue. And that was telling me this crop is lacking it's lacking nutrition. It's not happy, but it had just been given a huge amount of urea. So, that in itself doesn't make sense. It's showing that, well, all that urea is not enough and it's not a very efficient form because the plant had to go under stress to actually access it and convert it over. So because that plant has a lower Brix, it's also susceptible to insect attack. So what happens is, and this was explained to me wonderfully by Walter Yaner a few years ago, so plants obviously, they give out light, like a whatever colour light in accordance with their health. So, for example, if a plant has a low Brix, it'll give out a red light and that's like a beacon. So that's saying to all the insects flying around, I have a low Brix, you can come and land on me and pinch my sap and digest my sap because it's low. Whereas insects can't digest a plant that has a high Brix. So if they do try, they will die. So a plant that has, say, a Brix of 15 or higher or even 12, that will probably give out like a blue light. And that's like a warning. So those insects know, well, I'm not going to land on that one because I'm going to have trouble digesting those starches or I'll die if I do. So I'll just fly on and go to the neighbours or the one that's red. And that's nature's way of taking out the weaker species, which has been going on for millennia as well. So it's just being able to utilise. So that's my little rub with synthetic fertiliser. It interrupts that whole system and it's really inefficient. Like it's just, as scientists we work with say all the time, 80% of what you put out volatilises or is locked up in the soil within 2 to 3 days. So if you want to give your plants some nutrition, do it via a foliar. Like that's so much more efficient. And also for N to be absorbed quite efficiently by the plant, it really should go out with sulphur, boron and molybdenum because they form a triangle. that allows that N to be really easily accessed by the plant. So the plant doesn't have to expend that energy, that 15%, or use 50% of its water molecules to access it. But it's also getting those other essential minerals, and your zincs, iron, boron, copper. They're really essential to help plant fend off disease. So, and unfortunately, a lot of us use glyphosate. We use glyphosate on our farm. It's a really handy product to use, but it's a chelator in the sense that it ties up all the metal elements in your soil. So when you use it over a long period of time, which, for example, on my farm, it's been used since the 70s. And so we would have had a lot of lockup of all those metal elements. And then that's what leads to the Roundup not working that well. We had resistance. And you think about it, the weeds they're not that healthy because the soil isn't that healthy. It's unbalanced. So they can't access those metal elements, nor can the crop. And that's why a lot of crops that are grown in intensely farmed glyphosate use for decades soil have a lot of disease issues because they just can't access those metal elements anymore. And again, it's very simple to fix. Just get those microbes back that are meant to be in that soil, and they will start to sort that out and make those metal elements available again.
Wow, that is so much valuable information. I think a lot of the soil lovers will need to rewind and re-listen to that just because it was so well said. And like you said, a lot of people are not talking about this stuff, but it makes so much sense. It's like if a plant is growing in compact soil, and even just, for the roots to grow down, so much of its energy has to go just to drop roots rather than thriving. It's just in this kind of survival state. And then its bricks is, being altered. And then that's, creating a downward spiral of being attracted to bugs and then other things. And then it's subjective to frost because, there's more water molecules in the plant rather than the stuff that stops it from freezing. You can kind of see how this is a bit of a downward spiral. Maybe after the break, we'll talk about what that upward spiral looks like. So soil lovers, we're going to take a quick break and stick with us. Hey there, soil lovers. Did you know that there is now a digital agency that is committed and dedicated to soil caring businesses? Maybe it's you, or maybe you know someone who's really looking after our soils and they need to reach more customers. Well, finally, there is a marketing agency dedicated to soil caring businesses. They are soilconnect.com.au. In fact, it's one of my own businesses. I saw a need in the marketplace for a company that was good at marketing and digital, but also loved soil. Well, connecting those two interests together, I got Soil Connect. So head on over to the website and see what services we can help you with in order to amplify your soil caring activities. All right, enough from me. Back to the show. Welcome back, soil lovers. You're hanging out with Regen Ray and Keiran from Best Farming Systems. We've been talking about the stuff that a lot of people aren't talking about in the farming world, and that's really how plants function and work, and how a lot of plants are just barely surviving in the world of nature, and how we can set up systems for them to thrive. As I was just reflecting on that, it's kind of like, you can walk above the ground or you can walk in floodwater. When you walk in floodwater, it's a lot harder for us to walk through it. And then we're also wet, and then it's cold, and we're more likely to catch, a cold and not survive out in the wilderness. I think that's very similar to what you explained before the break, that plants that are in an environment that's not set up for them to survive just start kind of downward spiraling. Once you activate biology, what does that upward spiral look like, where plants start thriving and you need less inputs, and that your farm's kind of performing in its thriving state?
Oh, it's amazing, Ray. And it happens quite quickly. And that's what I find. I love to see that. No matter, I've seen some pretty ordinary soils that are very knocked about, and whether through just a history of a lot of traffic on them, overgrazing, a lot of chemical use, a lot of bare fallowing, the soil is really forgiving. And I've seen that soil bounce back fairly quickly. But you do need, the most important factor that you need to help the soil are growing plants. So, and the biostimulant, it's just a really powerful agent that allows that natural system to start to restore and return, and starts to build organic carbon in the soil again, because the organic carbon, as everyone would be aware, that is the key. That is what determines your moisture holding ability, your nutrition. That is the the big one. And you only have to increase your organic carbon by 1% or 1 point, and you will increase your soil fertility by 500%. So,
wow.
And that's another Walter Yaner nugget of gold that I love, that he just has some amazing facts and I can see that because, I mean, a lot of the soil I look at, I'd say the organic carbon would be below 1%. And I would love to see, I'd love to see it even at 3%. If farmers can just try and aim to get it up to 3. And so by doing that, I think that's what I love about a biostimulant. It's a really easy way without spending any extra money, without making any changes. And that's purely the reason my husband and I used it on our farm, because we didn't have to grow cover crops. We didn't have to buy any extra equipment. We didn't have to change our system. We just added it in with a herbicide. So it didn't even have to go out at a separate time. And we also put it on our seed instead of a pickle. So that's another really good start for a crop to actually, because as you can imagine, a seed, it's a really intelligent little package. It can sense temperature, moisture, its environment. If it's surrounded by a pickle, which is essentially a pretty nasty little poison zone, it's not very happy. It wants to just get away from that poison zone before it can head to the surface. And it's not in a very stable environment, because if it's gone into a soil that's not that well balanced, the temperature's not that great. It's having to expend a lot of energy already just to regulate and stabilise that temperature and try and keep itself alive before it can head up to the surface. Whereas if it's included or coated with a biostimulant, it's sensing that it's in a really rich ecosystem. So it's pretty happy. And if it's already had soil that's had PM applied or a biostimulant applied several weeks beforehand, and I'd really like to see a biostimulant go out around 6 to 8 weeks before a crop goes into the ground, because that's giving soil time, or the microbes time, to build up a population and start to improve that structure and be ready. So when that seed goes in, they are there. You've got that beautiful network ready to support that seed, and they're already saying, now what do you need? Do you need copper? And the plant will say, I need a bit of iron, all depending on what's going on minute by minute with the temperature and what's going on above the surface or the history of the soil. It'll just be supported with all the nutrition. So straight away we see that. We see a much more robust plant that's put down a huge root system. So it's got access to as much moisture and nutrition as it needs. And then it's resilient. It can handle if there's cold chock days, or if there's a big rain event, or what we've seen a lot of if there's not much rain. So another really important factor that people, I think, forget about is we do, even though where I live, we're in quite an arid climate, and it's all about moisture. Moisture is king out here. So farmers aren't that keen to cover crop or sacrifice their moisture. And that's where I find, and even in our system, we purely just use the biostimulant, and we use other products like a foliar that are encouraging and helping the system. They're not impeding it at all. So we just find we can actually get away with having a bare fallow over the summer, even though we have initially shut down that system. We're actually keeping those microbes going, because our biostimulant goes out in January or February, and it also goes out with a fulvic acid product, which will feed and fuel those microbes until there are growing plants back in that soil. So in that time, and we are actually monitoring the soil, and it's really encouraging to see we are starting to build carbon even in that fallow period, which is really great, because it's an indication that the microbes are there. They're not depleting. And even though there aren't growing crop plants in that soil, they're still doing their thing and building that carbon and improving that soil structure. So when that seed goes in, it's already got a huge network behind it supporting it. And I guess one of the first things I can see is the colour of the crop. I can always tell if it's a crop that's supported by healthy biology and healthy soil. It's a really lovely green. It's a really deep, natural green. I can always tell a highly fertilised crop. I call it nitrate green. It's a very iridescent, almost fluoro green. And doesn't really look, it looks artificially green. So, and then if you dig a few plants up, it's probably got fairly clean roots and not a lot going on as far as supporting it microbe-wise, whereas a healthy crop will just have those beautiful dreadlocks and it's getting everything it needs. And if it doesn't, if it's a situation where the crop, for example, you might, be back to back wheat, like you might just push the envelope and go 3 or 4 wheat crops in a row, which we're told we probably shouldn't do. But in a system where you do have all that different variants and biology supporting that crop and also all the nutrient availability in the soil, you can actually do that. I find with a lot of the farmers I work with, and even myself and my husband, we do push the envelope a bit. We can get away with doing things that normally you wouldn't do in a system if you're not encouraging that biology. So, and we don't use fungicides. We find because we have a high microbial population, those disease pathogens just don't survive. They're a really weak competitor. You only have to put a disease pathogen in a compost bin and it's gone in 2 minutes because they're not meant to be in that system. And the only reason that soils may have a high disease presence is there just aren't enough of those beneficial microbes and native microbes there to take them out and control them. So that's a really helpful factor. And also another little chestnut of knowledge that Walter Yaner, I remember he was doing some work in India with the UN, and it's all about over there obviously trying to grow crops and food security in a very arid, dry environment. So sorry, I jumped way forward. Getting back to being in an arid environment where I currently live, and it's all about moisture. Everyone is probably unaware or just forgets that we really can utilise what is known as that atmospheric rivers. So as everyone would be aware, we have a dew, like most mornings there's a dew. So that actually equates to between 2 and 4 mils of rainfall every night, or precipitation. So that actually ends up being between 4 and 8 inches of rain per year, which for us, that's pretty big. That's quite a significant. But what happens is, unless the plants, if they have a connection to the microbes, because when you're utilising your native microbes and the plants are healthy and they have that, what we call the green bridge, the communication between the plants and the microbes happening, then there would be like trillions of little microscopic microbes on the leaf surface of those plants. So they are able to at night harvest. They've got a capillary sucking action which harvests that moisture really efficiently. So they can actually access pretty much all of that atmospheric moisture or atmospheric rivers overnight, which was really interesting because we sort of put that to the test in 2019 on our own farm during the drought. So we had a few neighbours who didn't sow a crop at all and some who did sow and the crop died. So we only had half a profile of moisture. We had 22 mils of in-crop rain, which is not much, but we still managed to grow a not too bad crop at all. It was good protein, good test weights, low screenings. And John and I were saying, where is this plant getting its moisture? Like, how is this crop hanging on? But it was purely because it was able to efficiently harvest that moisture every night, and that was enough. And the microbes also were supporting that plant and regulating the temperature but giving it whatever nutrients it needed to cope with the stress of a very dry season. So that's where it's amazing. And also everyone also needs to bear in mind we can access atmospheric nitrogen. So that's when you have that green bridge functioning, that's the other benefit, that all those little microbes can access your atmospheric nitrogen, which is 78,000 tonnes above every hectare, because as we all know that the atmosphere is 78% N. So that's free, that's there. But unless your plants have that relationship with the microbes, they're not accessing it. So when they're given a lot of fertiliser, like nitrate-based, they'll stop trying to get that. It's just wasted. So that's where we really can utilise that whole natural system, because it's so clever and we really don't need to add anything. Once you get to a point where the soil is really healthy, you shouldn't need those other inputs like even the foliars. Only in times of extreme stress they might come in as a handy tool. But generally, although I do find just with our farming practices, probably always need to keep stimulating the microbes, because there are practices that unfortunately we just can't avoid, like traffic going through tractors, spray rigs, headers, cotton pickers going through the paddocks. That causes, the heavy traffic load of compaction. A lot of herbicides that we use and some fertilisers, they do impede the biology. So it's always helpful to keep building, because I do get asked sometimes by farmers, do you get to a point where you don't have to use this biostimulant? And it's completely up to them. We actually pulled a couple of paddocks out in the drought because nothing was happening. We weren't going to spray it on bare dirt. And the paddocks that we did try and keep crops growing in, that we grew those crops in during the drought, I've just noticed they are still so much further ahead. The paddocks where we just stopped because we weren't growing anything, things just paused and probably went backwards a little bit. So it sort of proved to us that, yes, you do need to keep. It's just a really helpful tool that you use every year to grow a good crop or good pasture.
Love that. That's so much words of wisdom and really well articulated. You really know your stuff. And I love the fact that you explain in a way where you kind of just get it. It's not too, over the top, and it makes so much common sense. And I just realized, reflect sometimes and realize like what led us to this point when now we're starting to zoom out and take a step backwards and realize that a lot of the stuff does happen on autopilot, and and having those little biologies working under the soil. It's like they're working 24/7, no sick days, no salary, no work cover, and definitely they're working for keeping nature all in balance. I know you also have a big focus on that whole end-to-end, where it's like soil health, plant health, animal health, and human health. And we've been speaking about the soil a lot. And I guess the real benefits is that when things are grown in this environment, we get better tasting food, more nutrient dense food. Can you quickly speak to that, link between the soil and then what we eat and then our own personal health?
Yeah, sure. So, and that's, I guess I'm really interested in just healthy food and overall general health, because it's all linked. Like a lot of what I do, I can tell it's replicated through human and animal health. And the stock farmers I work with, we can see the flow-on effect with the animals just because they're eating feed that is nutrient dense. So straight away they'll start to eat less, put on more muscle. I was talking to a farmer in WA a few weeks ago, and he's been using TM for probably more than 10 years now. And he just made the comment he hasn't had to drench for 5 years. And I was actually just on the phone earlier to another sheep farmer, and I was sort of explaining that to him. And it's similar to the soil scenario where you've got enough of the beneficial microbes are coming back. So they're taking out those pathogens in the gut of that animal. In this case, it was the sheep. So those little disease and those worm eggs that you don't want, they just can't survive. They're not thriving in that environment because the gut health is balanced again. And the same with humans. So what we have noticed, and I would really love to see this progress, and I think the consumers have to ask for it, is we are absolutely producing more nutrient-dense food. So back in 2017, I tested some durum that we grew here on our farm, and I actually sent it to George Weston Foods, who supply all of Tip Top across Australia, because I had heard, I think it was a podcast, or I'd read something a few years earlier where George Weston were getting to the point, or a lot of bread producers, where they were saying to the farmers, what the grain you're giving us, we're having to add iron to it now. We're having to add selenium, and, what's going on. And it's purely because, unfortunately, the system we're in, we're all driven by yield, and farmers, obviously they get paid for yield. So to achieve more yield, they're having to add more NPK to the soil or to the crop. But that's then causing problems with that imbalance that we've sort of touched on earlier. And as a result, the grain, it's not getting those other elements, those other minerals that are really important, like selenium, like silica, like iron and copper. So, and also, getting back to it may be a soil that's got a glyphosate history. So those metal elements aren't present anymore and they're not available to that plant. So anyway, to cut a long story short, we sent some grain to George Weston. They tested it for its nutrient density. So that's known as ash content in the bread world. And it came back as being, I think it was 8. The reading was 8, which was really high. And they compared it to another sample from this area. I think it was around Moree. That was like 4.7. So that was a fairly big difference. But then they said to me, oh, yeah, look, it's really good. We're really happy with it. The problem is it's going a little bit brown because it's got a higher bran content, and our customers like a white flour, so we'll have to bleach it. And the other problem is when it goes through our factory, it's, our development time for a loaf of bread is usually 2.5 hours, but your dough was so much stronger because of that higher nutrient content, it doubles. So we'll have to change all the machinery. And they said it's just, we can see the benefit, but it's not fitting in with our consumers and our timelines, and you're probably better to go to an artisan bakery. And so that was a bit disheartening because I really want the farmers who are doing the right thing. They're growing a much more nutrient-dense, better product. They're not being rewarded. So, and it was interesting because that same year I actually compared some grain from another TM farm against organic grain. And it was so much higher in nutritional density than the organic. And even though the organic was chemical-free, because the organic farmer wasn't facilitating their native biology, they didn't have that availability of nutrients to that plant like the system does with the TM or with the biostimulant. So they just weren't accessing that. And what's also is quite encouraging and exciting is even though on our farm, and I've tested several farms from across Australia like WA, New South Wales, Victoria, Queensland, we've all been analysing the grain. Even though we still use glyphosate, we still do an in-crop, for example, an MCPA or a selective grass spray, which are pretty nasty. Because we're utilising the microbes and the TM goes out with these selective herbicides or these knockdowns, it's breaking those residues down really quickly. So even though we'd used all these chemicals, it's still testing as chemical-free as well as being nutrient-dense. So that's really encouraging because it sort of proves that we can, I guess, utilise all that nutrition and the benefits of the microbes without having to change our farming system. We can still get away with using that chemistry, but it's getting flocculated out of the system really rapidly because of the active microbes. So there's so much potential there. If we can get the awareness, and I think the consumers need to ask for it, I'd love to see farmers, if we could have a biological market where it's not organic, and I know organic grain, for example, that might be worth a couple of $1,000 a tonne. These farmers should at least get 1,000 or even more because it's probably a little bit better. It's got that nutrient density and it's chemical free. So that's where it flows on. And I know it's also occurring with wheat. With wool. So there's a farmer who has just been tracking his wool strength. He's is it kPa with the wool and newtons. So that's been really increasing the last several years since he's been using the TM. So again, I think he is getting more because they get paid per their newtons. So that's sort of a better market he's getting into. But it would be so good if we could end up just to encourage farmers, those who are already doing the right thing, they will be rewarded. And those who are a little bit on the fence or think it's all a bit too hard or, they can't see enough in that first year, because I find some farmers, they expect to see a lot within a year and they don't understand with your biology, it's a system and you've got to rebuild it. It takes 2 to 3 years to really help it to recover and to ramp up again before you start to really see big improvements. But I usually always see changes, and that's why it's so important to get out on farm. But if they knew that they would also be financially rewarded at the end, they would be even more, encouraged to do this and to really start to look at their soil health and utilise their soil microbiology.
And such a great point in regards to consumers knowing that their demand on better quality food matters, because, you know, you just shared a story where you create highly good flour, but then the manufacturing process is your stop, you know, your wall, because they got to change their processing line, and, you know, they got to bleach it and all this other stuff. It's like, you know, the more that we demand that from those companies, then they'll have no choice but to change their manufacturing and then reward the farmer for that. Because I think you're right, you know, very disheartening to grow some great food, great product, and then it kind of has to go to a different, you know, system just because it's, you know, a too hard basket in the current one. Well, I think we could yarn for years and years and years on all this. So I think we should, you know, as you're speaking, I'm like, we need to do a webinar or something together where you can like share diagrams. You've got such gold, you know, wisdom that you're sharing, especially from Walter and so forth. You know, maybe a collab podcast or interview or webinar would be awesome. But we're going to have to wrap this up soon. So it's that time for you to become the voice of the soil. Are you ready?
Yep.
Excellent. So you have become the soil. You've embodied its energy, its power, its vibration, and you are its mouthpiece. What would you say as the soil?
I would say, please just keep respecting me. Just obviously stimulate the microbes. Just use some sort of biostimulant or something, but I find a biostimulant is the fastest way to just it can be like cover cropping just times 50. It just gets the results really rapidly. So, yeah, start using products that work with me, not against me. And I would say, as soil, I can handle pretty big chemical loads if I have enough of the indigenous microbes there to digest and flocculate them out of the system. So, yeah, treat me with respect, but use a biostimulant is probably my take-home message, because it is amazing just how forgiving the soil can be if it has a big enough microbial population there.
Love that. I think respect is definitely a great word, and knowing how it kind of functions and works. And you've done a great job explaining that to the soil lovers today listening in regards to, you know, better understanding. You know, we are farmers, we are soil lovers, but a lot of the people don't know how it actually works and the moving parts, you know. So I think, you know, shedding some light on that, and just, you know, the biological, you know, resistance that can be there in an event. And like, I'm so fascinated with the fact that, you know, even chemical traces can be removed from a system so quickly when the biology is there, you know. And so many farmers may lose their organic license or something because of an event, and they've had to do something. And yet if their biology was there, there would be no traces of that at the end product, which kind of blows my mind why we're not doing more of that. And just, you know, the biology should be the marker of the source of truth rather than any other kind of things.
Yeah, absolutely. And, you know, another example of how quickly it can buffer that chemistry out, we did some soil tests this summer. So we used a lot of pretty nasty herbicides like gramoxone, paraquat, a couple of Roundups. And after the last spray, which would have been a gramoxone Roundup, we took a soil sample. I sent it over to EAL to be analysed. 0 traces of herbicide found in the soil.
Wow.
So 2 weeks, and there weren't even growing plants in that soil. So that's really, and then my colleague in WA did the same thing, and he's had the same result. So it's amazing. That's really exciting, because it makes me realise, well, it's getting rid of that really rapidly out of the system, breaking it down, and then that's not causing further issues in the soil. So from a food perspective, that's awesome.
Yeah, you need the good organisms to outnumber the bad organisms, and it's always going to win, you know. Yeah, I think that's really fascinating. I think it's definitely an area that we don't talk enough about. And, you know, I think more research needs to be done around that, I guess, because, you know, everyone always wants to see the cited, you know, research papers. And I know you're working with a lot of farmers to create some of these trials and so forth. So it'd be very exciting to see some more of those results, you know, because, yeah, unfold over the months and years to come.
Yeah. And we're doing trials with Kalex, which is great. There's really good independent trials that are showing some amazing results, particularly with the carbon and reducing fertilizer, what's going on there as far as microbiology and also, yeah, just what farmers can achieve and when it's all done through laboratories, that's all scientifically backed. So we are getting a lot more tested, and it's all there in black and white for those. I know a lot of farmers do like to see proof or data, scientific data. So it's pretty easy to get hold of that these days. You just take a sample, pop it in the mail to the right lab, and you've got it.
There you go. Love that. Well, Keiran, how can people hang out with you more? I know most people probably want to reach out and see how they can, book some time with you or like hang out with you more. What's the best way that soil lovers can hang out with you?
Oh, so they could go to our website, bestfarming.com.au. So that's where my contact details, you can just link in and just hit the contact me for the newsletter or just for an update. So that way I probably won't give my phone number out because I might get
good choice.
But I'm available, and that's my role. I support all farmers across Australia and New Zealand. So I'm always happy to have a chat on the phone or email. If you're within a 3-hour driving distance, I'll come and see you personally. So our website is a good starting point. And then from there, it'll filter through to whoever's in your area. But I'm always happy to have a chat and set you on the journey because it's very simple. It's a really great way to look after your soil without making any major changes or spending a lot of money.
I think you've already inoculated a lot of people to go down this pathway today and open their eyes and ears and heart and mind to this new way of not new way, it's a very old way, but this new maybe paradigm for them to explore this bio-stimulant, way of doing farming. So thank you so much for coming and yarning all about soil.
Thank you, Ray. It's been wonderful.
Excellent. Well, there you go, soil lovers. Another episode for you to sink your teeth in. Until next time, make sure that you get outside, get your hands dirty, and keep digging deeper into our wonderful world of soil. I'll catch you on the next show. Well, soil lovers, that's enough secrets for one episode. I really hope that you enjoyed all the secrets shared during this conversation. But hey, let's not keep it a secret. Please share this podcast around and make sure that you like it and leave us a review because that really helps spread the secrets of the soil. Until next time, remember, get outside, get your hands dirty and keep digging deeper into your soils.